Okay, so we are gonna start with this small problem about molality, little m, and it is, what is molality of a solution containing 36.5 grams of hydrochloric acid, HCl, in 157 grams of water? So what we first have to do is write down the equation. Molality is little m is equal to, let's do it with pink. Let's do, it's equal to moles of solute over mass. This, do it in orange. Mass of solvent, but in kilograms. Alright, so to find our moles of solute, we have to find the molar mass of HCl, which is, I do it like this. We only have 1 of H, and we have 1 of chlorine, which is 35.45 grams, which is, add them up together and we get 36.46 grams. So we divide this and the grams that they give us, which is 36.5. So what we're gonna do is divide 36.5, 1 mole over here, this is grams, this is all HCl, so 1 mole divided by 36.46, which is the total of which is what 1 mole of HCl is equal to. We do that and we get an answer of 1.001 mole. Alright, and our mass of solvent is just 157 grams, but since it's in grams, we want it in kilograms. We're just gonna divide by 1000, and it's gonna be m is equal to 1.001 mole HCl over point, because we divided 157 kilograms of H2O. We do that and we get ourselves an answer of 6.37 mole per kilogram, and that is our molality. Another molality problem, which is, what is molality of a solution of 38 grams of cane sugar dissolved in 175 grams of water? So first we do the exact same thing over here. Moles solute over mass solvent in kilograms. Don't forget those kilograms. So we're gonna start with doing our moles too. So they gave us 38 grams. Always what they give us in here. So now we have to find out what 1 mole of cane sugar is equal to. So what I do is just, we have 6 H and O. Those are our 3 elements. How many of C we have? We have 12. H we have 22, and O we have 11. That times the actual number that they're worth each. So this is 12.01, this is 1.01, and this is basically just 16. We multiply all of them, and this would be equal to 144.12. This is equal to 22.22, and this is equal to 176.00. When you add them all together, you get molar weight of 1 mole is equal to 332.32 grams. So this, we're going to put it over here. 332.32 grams to make 1 mole of cane sugar, which when we divide those, it is equal to 0.111 mole. So we got our mole. So we're going to write the equation again. M is equal to 0.111 mole of cane sugar divided. So they gave us 175 in grams. We need it in kilograms. So we're just going to divide by 1,000. And by doing so, we're going to get 0.175 kilograms of H2O. When we do that, we are going to get a molality of 0.635 moles per kilogram. And that is our answer. There we go. Just by dividing, simple as that. So now we're moving on to the next problem, and this has to do with Henry's law. Henry's law, this is the equation for it is molarity equals Kp. Molarity here is moles over liters. Don't confuse that. K is a constant. It's actually Henry's constant. Although it's a constant, it kind of changes for each problem. And pressure. This is in atmospheres. So our problem is, if there are 4.5 moles of a gas in 300 milliliters of solution and pressure is equal to 5 atmospheres, what is K? So by reading the problem, we know that M is equal to, they give us moles. So that's the first part of the equation. So it's 4.5 over. The equation itself, the generic one, is in moles over liters. Here we have 300 milliliters. Simple, which is divided by 1,000, which will give us 0.3 liters. We do that and we get 1.5 M. Pressure, it is, they already tell us, so we just have to plug it in the equation, which is 1.5 M is equal to K. And since they already give us the 5 atmospheres, we just plug that in. K here is equal to 1.5 moles over, it's going to be 1.5 over 5 atmospheres. So our answer is going to be 3, just 3 moles per liter times atmosphere. That is our answer. Pretty simple, right? So now we're moving on to osmotic pressure. I wrote down the formula for this. Osmotic pressure is, in this case, pi. It is simplified by pi, and the formula is osmotic pressure is equal to IMRT. Now, I is equal to the Van Hoff factor, M is molarity, R is the ideal gas constant. That's actually a constant that never changes, and it is equal to 0.0821, and T is temperature in kelvins. So our problem here is going to be calculate osmotic pressure exerted by 0.495 moles of magnesium chloride, MgCl2, in 145 milliliter solution at 32 degrees Celsius. So let's write what we know. We need to find pi. So pi is going to be equal to, the Van Hoff's factor is the number of molecules this can be divided into. So we have MgCl2, Mg is 1, and Cl2, HCl counts as 1, so we have 2. So in this case, we count the total, and that's our Van Hoff's factor, which in this case is 3. Molarity, we have to do a little bit of math, but it's simple. Molarity, as we know, it's going to be moles over liters, and that is given to us. They give us the moles. We have 0.495, so that's going to be 0.495 moles over the liters, which is 145 milliliters. We have to convert that into liters, which is just 0.145 liters. We divide that and we get a molarity of 3.4 m. We get that, we put it into the formula. 3.4. R is a constant, as I said, that doesn't change. So, messed up. 0.0821. And T, we have to convert Celsius to Kelvin. That's pretty simple. They are giving us 32 degrees Celsius, 32 plus 273.15. It is equal to 330. I'm sorry guys, I did my math wrong. This is not 330. This is equal to 315.15. So we get that and we put it into our last part of our equation, which is 315.15. We multiplied all of that, and we get well, after we multiply all that, we get an osmotic pressure of 277.2. When I messed up again on the math, but I corrected myself. When we multiply all of these, we get a total of 263.9 atmospheres. And that is our osmotic pressure. Alrighty, our last problem of today. Look at my hands. They're all full of markers. So our last problem of today is the same osmotic pressure. It's just worded a little bit differently. We're not exactly looking for osmotic pressure, pi, but in this case, we're actually looking for one of the variables, which is T. So the question is, calculate temperature at which for 3.2 molarity of NaCl, it is equal to 30.1 atmospheres. So, as always, we write down what we know. And here we know that osmotic pressure is equal to 30.1 atmospheres. We know R, that's always a constant. We know molarity is equal to 3.2 m. And we know that our Van Hoff's factor, in this case, because of the NaCl, Na in this case is 1, and Cl is another one. So our Van Hoff's factor is equal to 2. When we write down the equation, it's gonna be the same as this one, but just write down, substitute it with what we have. So it's gonna be 30.1 is equal to 2 times 3.2 times our constant that never changes, times, well, in this case, we do not know our temperature. So this is just going to be x for right now. How we do that is we isolate this x by dividing the entire thing by 30.1. So I first like to multiply it. So all of this is going to be equal to 0.525. We know that now, so we got 30, oops, that looks like a 6, 30.1 over, with red, 0.525, that one's equal to T. So simple, just divide it, and we get our temperature in Kelvin. Simple as that, right? We're done.